Okay, good afternoon once again. So we are now ready to tackle about our next topic, which is rocks. Okay, so for our objectives for this lesson, okay, so you as learners will be able to classify rocks into igneous, sedimentary, and metamorphic rock. So at the end of the lesson, you as learners will be able to first explain the rock cycle. Second, classify rocks into igneous, sedimentary, and metamorphic rocks. And lastly, appreciate the importance of rocks in our daily life. So, we have mentioned before what are rocks and what rocks are made of. So, if we're going to go back to our discussion about minerals, we can see that, okay, we can recall that rocks are actually aggregate of minerals. So, meaning they are composed of different minerals, or it can be composed of a single mineral. An example of that is quartzite, which is actually a metamorphic rock composed of predominantly of quartz, or it can be composed of two or more minerals. So rock types, it can be monomineralic or polymineralic. Monomineralic, an example of this is limestone or quartzite. So monomineralic is composed only of one mineral. So an example of this is calcite belonging to the carbonate group, if you can still recall. And then quartzite belongs to the silicates. And then we also have the polymineralic granite or granite, which is composed of quartz, feldspar, and mica and other uh, minerals. So there are three types of rocks. If you can recall in your science in junior high school, there are three types: the igneous, sedimentary, and metamorphic rocks. So here I have different images or pictures of rocks, and I want you to identify whether it's an igneous, sedimentary, or metamorphic rock. Okay, the first one is obsidian. Okay, can you take a wild guess? Okay, if your answer is igneous, then you're correct. So obsidian is an example of igneous rock. So if you can see here, it is glassy in appearance. Okay, next, shale. Okay, shale is a type of, or is an example of a sedimentary rock. Okay, next, gneiss. So we pronounce this as gneiss. So gneiss is an example of a metamorphic rock. Okay, so you can see here foliation or striations. So we call that as foliation, or it is foliated. Okay, next we have conglomerate. Okay, you can see here uh, pebbles embedded in a matrix of sand. Okay, so we have here conglomerate. Yes, you're correct. It's an example of a sedimentary rock. Okay, next we have gabbro. Okay, if your guess is igneous, then you're correct. So gabbro is an example of an igneous rock. Okay, how about marble? Okay, so marble is an example of a metamorphic rock. So later we're going to differentiate the different types of rocks and what makes them igneous, sedimentary, and metamorphic. Okay, lastly, we have bituminous coal. Is it sedimentary, igneous, or metamorphic? Well, if your guess is sedimentary, then you're correct. So this is an example of a sedimentary rock. So how do we classify rocks if we're going to ask ourselves? Would it be by color, hardness, texture, density, or other physical properties? Or is it by chemical composition? So today we're going to identify the different kinds of rocks by using characteristics or okay, as we go on or as we go through our discussion. First, we have igneous rocks. So igneous rocks from the Latin word ignis meaning fire. So igneous rocks are formed when molten or partially molten material called magma cools and solidifies. So this is derived from the cooling and solidification of magma or lava. If it's still inside or underground, that's magma, and then if it comes out, it's already lava, it's flowing. From solidified molten rock materials, usually hard and crystalline. So an example of that is, a while ago we had gabbro. Okay, so you will see here the crystals. Okay, they are very evident. Okay, the rate of cooling is one of the most important factors that control crystal size. So whether the crystal sizes, how small or how big it is, depends on the rate of cooling or how fast or slow the cooling is. So solidification can occur along the surface of the earth or beneath the surface of the earth. That's why we have two classifications of igneous rocks. So this is according to the depth of formation. So we have plutonic or intrusive igneous rocks and volcanic or extrusive igneous rocks. So let's try to talk about the two. Okay, first we have intrusive igneous rocks. So intrusive igneous rocks are solidified or they come from solidified magma underneath the earth. So there's a gradual lowering of temperature causing from the movement of magma from the depth to the surface, causing slow cooling or slow crystallizations, thereby forming large crystals or phaneretic textures. Okay, so phaneretic texture describes a certain intrusive rocks as having large or easily visible interlocking crystals. Okay, so anyway, I'm going to show you the difference between or among the difference between the different types of intrusive or the textures of intrusive igneous rocks. Okay, intrusive granite or the intrusive rocks, okay, if this is the magma, okay, there's a slow cooling, okay, therefore making large crystals. Okay, so that's an example of igneous intrusion. There's an igneous intrusion, thereby forming intrusive igneous rocks. An example of an intrusive igneous is granite. While extrusive igneous rocks, there's quick cooling. Okay, from the magma chamber, it is pushed up through volcanic eruption. So there's pressure. So the resulting lava will cool down and later on will form an extrusive igneous rocks. And the crystals are a bit small or glassy in texture since there's quick cooling. An example of this is the one that we had a while ago, okay, the obsidian. If you're going to look at it, okay, you cannot see the crystals anymore, but rather its texture is glassy due to the fast rate of cooling. So extrusive igneous rocks, on the other hand, we have here an example. We have rhyolite, andesite, and pumice. So they have different textures as well. So we have aphanitic, porphyritic, and vesicular. So what are the difference between or with these different textures? So if you're going to look at the rhyolite, it has an aphanitic texture. So aphanitic, the texture describes a very fine-grained rock where individual crystals can be seen only with the aid of microscope. So you can see the crystals, but it's not really that visible. Okay. Next is porphyritic. So for porphyritic, this texture describes a rock that has well-formed crystals. So you can see it here. Here are the crystals that are visible to the naked eye. So what's the reason why we have this kind of texture? So a porphyritic texture is developed when magma that has been slowly cooling and crystallizing within the earth crust is suddenly erupted at the surface, causing the remaining uncrystallized magma to cool rapidly. That's why we also have, it's like a mixture of large and very fine crystals. Okay, so these are very common, or this texture is characteristic of most volcanic rocks. And last one, we have the vesicular. An example of vesicular is the pumice. Okay, so due to the rapid, when it gets out of the volcano, so during volcanic eruption, there is a formation of vesicles, okay, or bubbles. Bubbles are trapped here in your magma. So forming air vesicles, so we have vesicular. So again, the different types of texture, we have fine grained or rhyolite or aphanitic. So this is an example of an aphanitic texture. Aphanitic. Okay. So fast rate of cooling, it has voids, vesicles left by gas bubbles that escape as the magma solidifies. Crystals are too small to see without magnification. So we also have coarse grain. So crystals are very visible due to the slow rate of cooling. So large masses of magma that solidify far below the surface. And individual crystals are large enough to see without the use of any magnification. So an example of this is granite. So you can see here the different crystals. Crystals of quartz, of uh, amphibole, okay, for granite. And then, quartz, potassium feldspar, so you can see it there. Yeah, amphibole and biotite. Then porphyritic, so there are two rates of cooling. So this one is phaneretic. Phaneretic. And then the next one is porphyritic. So due to the two rates of cooling, so it is slowly cooling inside the or underneath the earth, or no, underneath the ground or underground, and then it is pushed up due to volcanic eruption. That's why we have two types of, or the two rates of cooling. So it has large crystals embedded in a matrix of smaller crystals. So example of that, we have the andesite. And then last one, we have glassy. So due to the very fast rate of cooling, so it looks glassy in texture. So that's obsidian. And we also have the vesicular, trapped with air bubbles. We also have pyroclastic rocks. So these are fragmental rocks usually associated with violent or explosive type of eruption.